Good morning, everyone, and a very warm welcome on this first thematic event of SOILL-Startup project. Thank you for joining us today. As SOILL-Startup, we are delighted to host this webinar that addresses a crucial topic for soil health. So we are especially proud to organize this event in collaboration with so many mission soil projects. Although it's a week or already past the official date of World Soil Day that was celebrated on 5th of December, today events continues to amplify this year's theme, which was caring for soils, measure, monitor, and manage. My name is Gabriela Rogowska, and together with my colleagues Gabriele Quattrocchi and Fabiana De Carlo, we represent Trust IT Services, a communication partner for a SOILL-Startup. So before we begin, let me go through some housekeeping rules. This webinar is being recorded and will be published on the SOILL-Startup website, including the presentations of each speaker. So if you don't want to appear in the recording, please avoid turning on your camera and anonymize your Zoom name accordingly. As you know, during the registration phase, you already had a possibility to ask your questions, and we collect them. We will try to address them at the end of the session. However, you can. We encourage you to type your questions in the dedicated Q&A box. You can see also that there is a chat, so please keep an eye on that. My colleagues will paste them some useful links, and feel free to use the chat for general comments and networking. So you can even now start present yourself if you want to in the chat. Finally, we will share with you the feedback survey, so you can also suggest us some future topics that you would like us to cover. And before introducing our speakers, let me warmly welcome all of you who have joined us today. This event has attracted a wide range of soil stakeholders. It is really impressive, with almost 460 unique registrations from 67 countries from all around the world. So thank you for being with us. And you can see here a breakdown of the registrants. And we are pleased to see balanced gender representation as well. And as you can see, the audience includes a variety of stakeholder groups. Research and academia represents half of our audience today, but we are also joined by representatives from industry, mission soil projects, farmer associations, industry associations, national authorities, regional authorities, land managers, and mission soil living labs. So a warm welcome to everyone. And now let me introduce our speakers for today. So our first speaker is Orwin Rhys-Jones, Deputy Head of Unit at the European Commission's Joint Research Centre, where he leads the development of EU Soil Observatory. Then we will have representatives from EU Mission Soil projects. First up, we have Giulia Campodonico, Mission Soil Coordinator, Soil Startup Coordinator. We'll have Paolo Di Leonardo from Benchmarks, following David Robinson from AI4Soil Health, and next Martin Torschow from MARVIC and Soil Valley projects, and last but certainly not least, Dimitra Palanza from MARVIC for SOC. So I think we are ready now. So let's get started. And please welcome Arwin Rich-Jones. So Arwin, the floor is yours. You can share your screen now. And thank you very much.
So can you hear me, first of all?
Good morning. Yes,
Yeah,
loud and
great.
clear.
And hopefully you can see the presentation as well, yes?
Yes, all good. Thank you, Arwin.
So indeed, yes, good morning. And also thank you for the opportunity to present to you, let's say, some overview of where we are at the moment in terms of soil, and especially in terms of the soil monitoring law from a European Union perspective. Indeed, just to explain maybe who we are, the Joint Research Centre is the sort of the in-house science and research part of the European Commission. And our task is to provide, let's say, robust science and evidence and knowledge for EU policies and legislation. And specifically this morning, I'm going to focus on what we're doing under the umbrella of the soil monitoring law. Let's see if it goes. Okay. So you may be aware that the EU in 2021 adopted a new soil strategy for the European Union, with basically the commitment that by 2050, all soils in the EU would be in a healthy condition. Therefore, they will be more resilient to pressures and be able to deliver a balanced set of ecosystem services. And that in order to get to this point, then obviously soil protection, the sustainable use of soils and soil restoration will be widespread across the territory of the European Union. In this case, then, soils will be able to support, the implementation of the Green Deal. Now it's called the green transition, so that we can mitigate the effects of climate change, protect biodiversity, mitigate the impact of natural disasters, such as flooding, as we saw in Spain and in Central Europe during this autumn. But also to provide resilience against drought, whole desertification, but also to increase the EU security in terms of its capacity to produce food and support then the development of bioeconomies. And finally, also that healthy soils also mean healthy people in terms of balanced diets and so on. So the soil monitoring law has, let's say, a set of objectives to help us get to this this aspect. It gives let's say, a legal definition of what a healthy soil is and criteria against which soils can be measured. It sets up the mechanism for the establishment of a monitoring framework for member states. It has an let's say, a provision to highlight a range of sustainable soil management practices, and that this I think is the key link to the audience this morning, and I'll come back to that later on. It also asks member states to address contaminated sites, to make an inventory repository, and then to do a risk assessment, and then to look at restoration in the long term. And then it asks member states to report progress on all of these aspects on a regular basis. So basically, the law has these sort of four key pillars that I've sort of identified. That soil health is assessed on the basis of physical, chemical, and biological characteristics. And member states will be asked to define practices that should be implemented to stop soil degradation. I mentioned the point about the contaminated site. And also, there should be an approach to look at the issue of land take. So to understand what are the drivers of land take, how to reduce and how to mitigate their impacts on soil condition and ecosystem services. So currently, there's a legislative process going through. For those of you not familiar with how the EU works, the Commission has made a proposal for the law. This is then debated and assessed by the European Parliament, and they came to a positive conclusion in April of this year. In parallel, the texts were assessed by the member states under the various sort of presidencies of the EU, and a position was adopted also there by the member states in the summer of this year. So now we're in this process known as the trialogue, where basically we look to achieve consensus between the version of the proposed law that was adopted by the Parliament and that by the member states. This process started in the autumn, and basically they go through the text article by article and recital by recital and look at where there is compromise. Let's say the main issue is that there are two, let's say, different approaches on how soil should be considered. The Commission proposed with the Council that even if one indicator of soil health, let's say, was failed, then the soil was deemed to be unhealthy. In contrast, the Parliament would like a more nuanced approach where there could be a sort of maybe a more of a traffic light system that ranked soils in terms of severity of issues. Also, we have this concept now that member states were asked to define soil district, but now we have a new, let's say, flavor where within soil districts, which are administrative regions, we have the concept of homogeneous soil units, basically, and how the intrinsic characteristics of the soils need to be considered when we assess their condition. And a program that the JRC carries out, known as Lucas Soil, should be adapted and taken forward and used to support member states and where needed in the collection of data. So that's basically more in terms of the scene setting, but I just want to give a few minutes now in relation to some challenges. And I think one challenge we have is shown on this map here, where all these colors obviously represent different types of soil. So we have a very broad regional often regional characteristics of soils, which determine how they are used, how they are managed, how they respond also to certain management practices. And other consideration is what is healthy for one soil may be perfectly normal for another. So if you look at the soil on the right-hand side here from Finland, very low pH is natural characteristics, and you can't then say that this soil is unhealthy on the basis of low pH because that's its natural condition. While if the one on the left from Hungary, for example, if that pH was dropping substantially over time, then one would say that this was in an unhealthy situation. So we have to bear in mind the context of the soils that we're measuring, and indeed also on how they're being used. So at the JRC, we have this concept of the EU Soil Observatory, where basically we try to provide knowledge for policymakers and other stakeholders, such as the people involved in living laboratories, where we collect data on the health of soils from across the EU, bring it together, try to integrate it so that it feeds indicators and eventually dashboards that demonstrate whether actions and policies are having an impact on soil health. We also, in doing this, find gaps in our knowledge and understanding. So we have the soil mission, which we've heard about, as a mechanism to help us fill these knowledge gaps and maybe develop new tools and techniques to assess soil health, which we can then feed into the process. So basically, the JRC is being asked to develop a digital soil health data portal, which will be, let's say, the key focus of data and knowledge relating to soils. To do that, we need to upgrade our data center, also this SOILL module, and also provide some specific guidelines to member states. The soil health portal will be based roughly on this soil degradation dashboard that we've developed over the past sort of year and a half, where we try to collect scientific evidence on the impact of soil degradation processes across the EU. But one could see that eventually the map that we have here, where dark areas represent increasing areas of degradational pressures, will be replaced by data that's collected by member states on soil health. And we bring it together to give a European perspective. But as I said, the portal should be more than data. It should also be, let's say, information on supporting evidence. So one could consider how the laboratory analysis has been carried out, what land management practices are being used, and also the possibility to share best practices on sustainable soil management. And this is where the living labs concept comes in as being as a critical element, because here we have the possibility to investigate novel approaches to soil management. Because I think it's important to stress that the soil monitoring law is a monitoring tool at a European level. So it will collect samples in the field, feed into, let's say, a network, and allow us to provide assessments on the state of soils in the EU. However, it's not, let's say, necessarily a farm support tool, or a land management support tool. And again, data collected at field level through living labs, through farmers testing, should eventually also feed into this this circle. So we have the need to have different scales of measuring and different scales of assessing also the impact. And I think probably David will talk a bit further on this later on. One thing that's important for us is that where possible, we try to standardize data collection. So we have, let's say, suggested recommendations or guidelines on how samples can be collected. And if you're involved in a living lab and you're collecting soil samples for analysis to assess baselines or to look at progress, we will suggest that you maybe follow the guidelines that you can find on our website, and we can share the links during the meeting as well. Finally, I just want to say that one of our key tasks starting next year will be to establish a number of guidelines for member states. And here also we want to be able to include examples where we have also good practices, for example, in terms of addressing certain soil degradational processes, practices that show that they assist soil remediation if you're dealing with contaminated sites and so on. And so it's important for us to have the feedback from projects that are active in the living labs to feed in our knowledge, so we can disseminate this as well. So I think that's the end of my time slot. I'm happy to take any questions either via the chat or in person, and I'll be around for the rest of the morning as well. So thank you very much for that.
Thank you, Erwin. Thank you so much. It was extremely informative and great to have you here today. So now we have hear from Mission Soil Projects. We have representatives of 6 projects here today, And now please welcome Giulia Compadonico, SOILL-Startup Coordinator and Head of Project at ENOL. Giulia will introduce SOILL-Startup Monitoring Framework for soil health living labs and lighthouses. Over to you, Giulia.
Thank you very much and welcome to everyone. Really glad to be here with you today. So let me say that our presentation is a bit different from what probably you will expect from the other colleagues, because we have a different approach to monitoring. Indeed, as Gabriela mentioned, we are targeting the monitoring of living labs and lighthouses of the mission soil. But before doing that, let me introduce what SOILL and SOILL startups are. So SOILL is a framework partnership that is running since this year and will run until the end of the mission soil, and that aims to create this one-stop shop support structure for the mission soil living labs and lighthouses. So really supporting the 100+ living labs and lighthouses along their journey. And in the framework of this of SOILL, we have the first operating project as a SOILL-Startup that is also inviting you today to this webinar. And in particular here in the first 2 years of the partnership, so for 24 and 25, we're working on co-designing and set up and start up this structure for support, mainly collaboration with the first funded living labs and lighthouses. So what does SOILL-Startup offer to the, we start with coordination and support. So we know we will have different living labs along the way, and we want to be the primary contacts, both for the living labs to access information, but also for the wider soil community to access information on living labs, to have a centralized point of reference. We want to engage and promote the work of the living labs. You will see later, we already started presenting the different living labs in a catalog, but we will also facilitate the engagement, the promotion of the results of the living labs, and also facilitate the exchange with the living labs. We are developing a learning journey with online, in-person mentoring activities and a help desk to support primarily the living labs, but also the future living lab applicants or the wider community who wants to know and engage and collaborate with the living labs. And talking of collaboration, we have a dedicated set of activities to facilitate the exchange within the living labs, but also within the living labs with the wider soil community, with knowledge sharing events that we will start running from next year. And the reason why we're also participating today is because we have indeed this monitoring and assessment framework with guidelines, reporting and recommendation that I will present better later. And all this will be managed and accessible to the entire soil community through the Soil Hub, which is a web platform where you will be able to not only to get information from the living labs, but also to receive, to communicate, exchange with the living labs and access the knowledge repository of support materials and tools we are developing and that the living labs will develop. But who are we talking to? Who are our main stakeholders? So first of all, of course, is the funded living labs, since SOILL is a support structure for them. As of 2025, we will also continue the support initiated in the last years by the Nations project. So we will support all the applicants that will be interested in becoming a living labs and benefit and apply to the different fundings offered by the Mission SOILL for establishing living labs. We are working also in close collaboration with the Mission SOILL, the Secretariat, the Mission Board, and the Mission Support Platform. As we see today, we are working in close collaboration with many mission projects that can contribute to support the work of the living labs. And finally, we are open to collaborate and establish relations with a wider soil community. So, but as we mentioned, there are already 25 mission soil living labs that have been funded by the 2023 dedicated topics. Here you have a presentation, but if you want to know them better, some of them I see are present in the webinar, but you can also browse the catalog here to really understand better their goal and their targets and their peculiarities. But we say we are going to have more than 100. So first of all, let's consider the different waves. So in 2024, as I mentioned, the 25 first living labs are started. In next year, we expect the second wave of living labs and so on until 2028. In theory, we expect to have 100 living labs, but we want to go beyond the 100 living labs. And why that? So as you can read also in the prep soil taxonomy that has been developed by the Prep Soil project, we have a differentiation of living labs and lighthouses. First of all, we have the mission soil living labs. These are those that are funded specifically by the dedicated topics. As we said, we have 25 that are coming from the 5 first projects, Go for All, EcoShells, Lilas for Soil, Living Soil, and Socrates, that applied to the 2023 topics. But this will not be sufficient. We want to go beyond the living labs that are funded by the mission and consider all other living labs at European level that are not funded by the dedicated funding opportunities, but that still align to the mission criteria and therefore can collaborate with the mission soil living labs for a wider network and more effect to support soil health. We will also work with the emerging soil living labs and lighthouses that are preliminary initiatives to support them grow up if they have the intention, of course, and ensure that they can grow and contribute to the wider network. Before entering into the monitoring framework we are designing to soil, it's important to understand the systemic approach of the mission soil. I believe all of you are familiar with the mission soil that aims to use the 100 living labs and lighthouses to lead a transition to healthy soils. But reading, for example, the mission implementation plan of the mission soil, we can clearly identify 8 specific objectives that drive the expected impact that also Orwin was mentioning before to really address the degradation and improve soil health across Europe. But to do this, we also need to consider the way this impact is achieved. And that's why in the mission implementation plan, we can find 4 operational objectives that drive the way. And one of these is identifying the living labs as the main vehicle. But how the living labs needs to operate, we have that's how the soil approach is considering. So deriving from the soil, from the mission systemic approach, we use the same systemic approach also in define the monitoring to living labs and lighthouses. So we integrate on one side the living lab approach, deriving from the experience of the international network that ENOL represents, but also on the specific criteria identified in the mission soil implementation plan, but also considering the impact for soil health, therefore aligning with the EU soil monitoring law and all the indications that Orwin and Yuzo are providing and so on. And for this, we have, it's a long path that we are almost concluding. So we started from the living lab harmonized evaluation process that ENOL uses to certify living labs. Then this has been complemented by the criteria identified in the mission implementation plan, the taxonomy derived by the defined by the Prep Soil project for living labs and lighthouses, and then the monitoring framework in soil that puts together, as we said, both the living lab approach and an analysis and contribution of the living labs to soil health impact. For this, we have created this framework structured along 5 monitoring and evaluation chapters that really covers all the different steps and looking at establishing living labs that do not only think of the time of the now and the activities and the commitments in the respective projects, but really look beyond and try to be sustainable and stable and viable beyond the duration of the projects for them to really support the transition to healthy soils even beyond 2030 and the end of the mission. As we see, we have goals until 2050, sorry. And that's why we consider different chapters: strategy, the operations, the openness, the user and reality, really looking more at how the living lab is structured and looking long term, but also the impact and monitoring and how the living labs contributes to the monitoring and impact on soil health. Why do we create and what will we use this reporting and assessment for? So first of all, it's the goal, considering we are a support structure for living labs, is to monitor, evaluate, and learn. So monitoring the living lab progress and develop based on the results a targeted capacity building through the soil learning journey, but also it will be a tool for the living labs to self-evaluate and track progress over time, so to understand how they are progressing. Then we will use it for labeling. As we saw before, we aim to go beyond the 100. So this framework will also be used to identify which other European initiatives are fully aligned to the mission objectives and living labs and lighthouses criteria for them to be labeled as European soil living labs, and to report and data. So we will, of course, contribute on the mission progress through the detailed reporting with to the mission secretariat, but also we want to streamline and harmonize the contribution that the living labs and the lighthouses really operating in the real life scenarios and producing data can contribute to the European soil data and knowledge, so in collaboration with USO, but also beyond. And finally, advocacy. We see that it's important that policy is updated and reflecting the current state of the art, the progress of research, and this is what we will do, also with recommendations to future applicants, the network of living labs, other mission projects, identify maybe how they can complement the support activities, and all other actors. This is something, of course, that will come in the upcoming years, especially the last part, because now we are starting to monitor the living labs. But if you want to collaborate with us, of course, we are happy for you to join us. Here you can scan and enroll in our stakeholder mapping community, and we will be happy to enroll any interested collaborators. And with this, I thank you a lot for your attention, and hope to be able to address eventual questions later.
Thank you, Julia. Thank you for this overview. I think that we have all a much clearer understanding of what we are doing at SOILL-Startup. And just a reminder that the slides and recording will be made available on our website. So no need to screenshot. We ensure that we will make them available as soon as possible. So our next speaker is Paolo Di Leonardo from Soil Health Benchmarks. So Paolo, you can start sharing your screen. Paolo plays a leading role in advancing the science and application of soil health monitoring. So over to you, Paolo.
Thank you for the introduction, and thanks for giving me the opportunity to present a Benchmarks project. And in the next few minutes, I will explain a bit what we have been doing the last 2 years. It's when the project started in January 2023. This picture represents quite well the aspects of the methodology of benchmarks. Indeed, we work across scales and land uses, and including like different type of measurements. On the left-hand side, we see that different icons. Indeed, we work with measurements with wet chemistry based, let's say classical methods for physical, chemical, and biological parameters. But we also include, in terms of measurement, proximal and remote sensing, so drones and satellites, as well as near and near approaches, but also with big data set, existing or data that we are going to collect. We work in different land uses, not only the classical, I would say, agricultural one, but also include forestry and urban systems. And we follow a bottom-up approach in terms of scales from local to landscape, regional, and European. And most importantly, we also want to know what are the needs of different type of stakeholders as land managers, or policymakers, and value chains businesses. And this part especially was one address at the beginning of the project, where we wanted to test the hypothesis that soil health is perceived by different stakeholders in a different way. So depending who they are and where they are. And to test this, we ran 21 different workshops, multi-stakeholder workshops connected to our case studies spread across Europe. And we asked 3 main questions. What are the challenges that they face according to where they are and who they are? which soil functions they have a value as the most important. So we ask to rank them, as well as how they can support us in this type of initiatives, but also how can we support them with the exchange and of knowledge. And this is a very brief snapshot of the many results we got, and this will be published soon as a deliverable and will be widely available. For example, if in total, in a cumulative of the results, we saw, for example, that on the left-hand side graph, the radar plot, soil compaction is considered to be one of the biggest challenges, while for example, the policy limitation is not perceived to be a big challenge. And this is a cumulative approach, but we have different results also for the different workshops. And this is, for example, we see it on the left-hand side where in yellow are represented the totality of the workshop together, and in green, the single workshop, in this case was the one in Switzerland, if I'm correct, where we see that if the function water regulation is valued important at the cumulative level and a single level, we see, for example, the primary productivity on the left side of the panel actually is valued not so important in this specific case. This already starts to give us an idea how different stakeholders and different contexts and different pedoclimatic zones also value, they have different issues and different understanding of soil health. Of course, this stakeholder approach is also we are going to support our scientific underpinning of the project. This is schematization of our knowledge base. So where we define soil functions, we try to understand the bundle of processes that support the different functions, and we split them in sub-functions, processes, and we link the different parameters as biological, chemical, environmental, and physical parameters, how they are linked and affect the different processes. And it's also, in my humble opinion, very interesting that we are trying to link the different management practices, how this can affect processes and parameters, but as well try to pinpoint the different types of indicators and what they measure at which level. For example, indicator 1 can measure a function, but actually if you choose a different indicator, actually it's more fit to assess a biological parameter. This because the final product of benchmark should be a tailor-made approach, like a logical sieve approach for a decision-making for different users to understand, to decide which type of indicators to use depending on what they want, depending on the context and the purpose that they have. This scientific base, these cognitive models are supported by data, so existing but also collecting. That's what we have in our 29 landscape case studies spread across Europe and for the 3 land use systems. And we categorize them in 3 main groups. We have replicated long-term experiments, both in the agriculture and the forestry system. And they are experiments mostly connected to research centers and the universities, well known, and we are going to test indicators there. We also have variant sites where we would like, both in agriculture and forest system, when we are going to test the landscape variability. And then we have the urban site, urban cities, where we want to test indicators to can keep and address the fragmentation in different areas, also spread across Europe. For each of these group of units, let's say, or group of system, we define different protocols, sampling protocols, because we believe that we need an harmonization. And we have a training session really explaining how to sample, and also a sampling core team that visit all the different case studies, really assuring that the procedures were homogenized. As well as we don't ask to one lab to run all the different analyses, but we did send the different samples to different labs, because each lab is responsible to 2-3 analyses to be sure that we really homogenize the methodologies. And this will assure that the difference that we see are related not to the different methods, but really to the differences that we see in the field. And we try to have a spatial variability in terms of landscape, as well in a vertical, if I can say that, like we did sample at different horizons, at different layers for the horizons, as well as a temporal measurements, temporal variability. We have a 3 years field campaign. We started this year, 2024, for the agriculture and forest systems, and this will continue until 2026, where we also sample at landscape level, while the urban sites are assembled next year, starting in April. This is a list and was defined recently in a project meeting, the Christmas list almost of indicators. And you see it's very thorough. It comprehends many different types of measurements and indicators. And the idea is that you want to test as many as possible in this first part. And then by the end of next year, hopefully even before, trying to understand which one are the most sensitive according to the different contexts and also according to the purpose. So we'll try to already try to make to give possibilities to choose according where you are. Of course, this work is not done only by me and not only by Wageningen University that we are the coordinator, but we have many partners. We are 28 in total with 150 people joining the consortiums. And these are pictures from the kickoff meeting and the first project meeting this year in February in Coimbra. But as well, we like to collaborate and connect with many different projects as SOIL, AI4Soil Health, it's our sister project. And together with AI4Soil Health, we coordinate the soil monitoring and indicator cluster supported by the Mission Soil platform. These pictures are from last year meeting in Madrid. We have another one in Brussels, and I have to say, in my opinion, was quite successful. And hopefully we have another in-person meeting by next summer, together with all of you, hopefully. And with this, I'd like to conclude my presentation, and I'm happy to take questions at the end of the session. Thank you.
Thank you, Paolo. Thank you for this presentation and illustrating the efforts behind the benchmarks. And next, let's welcome David Robinson. David is a principal soil scientist at the UK Centre for Ecology and Hydrology. David's work focuses on soil physics. And David, the floor is yours.
Yeah, thanks very much. So, and welcome from AI4Soil Health this morning. So, we're kind of zooming out now because AI4Soil Health is very much based at this sort of pan-European scale. And we do a lot of work with JRC, so that will come up. So the focus of the project is this European-wide digital infrastructure that we've termed AI4Soil Health. So that is the aim of the project in developing that.
Can't hear you anymore, David. Are you with us? In case we can proceed, maybe, David? I think we lost connection. So maybe if it's not a problem, we can proceed with Martin's presentation. So maybe we can interrupt the screen sharing by David. And I would ask Martin to share his presentation, and we will wait for the presentation of David. Thank you so much, Martin, for being so flexible. And so Martin Thorshaw is Associate Professor at Aarhus University, working on the MARVIC project, and he representing also Soil Valley project. So Martin, over to you.
Yes, thanks a lot. And I'm a social scientist, so my work is also focusing specifically on the farmer as a decision maker in relation to a lot of these landscape changes that are needed in order to implement all the ambitions we have with respect to soil health. But yeah, today I'll present the MARVIC project and some of the work that we do in the MARVIC project. I'm involved in work package 4, which is about socioeconomic aspects of carbon farming. Let's see if I can change. Yeah, and the project is coordinated by ILVO, but other than that, we are 12 countries represented in the project. And you can see the spread here at the map. And the focus of the project is to develop and test a framework for the design of harmonized context-specific monitoring, reporting, and verification systems for soil carbon and greenhouse gas balances, focusing primarily on agricultural activities. We work with 4 specific soil types and land uses, on arable land and mineral soils, on grassland, on agroforestry and wooded crops, and then finally on managed peatlands. And we started out last year in June and going on until 27. So we are still in the beginning of the project, but also starts to have some results coming in. And the context of the project is this ambition to lower the greenhouse gas emissions, specifically focus on agriculture, and how we can sequester 42 megatons of carbon using carbon farming practices. And when we look at carbon farming, we're considering it as a green business model that rewards land managers for taking up improved land management practices, resulting in increasing carbon stocks. And last year there was a framework adopted by the Commission on carbon farming removal certification. Earlier this year, and also earlier this year there was the nature restoration law, where there's a focus on restoring peatlands and rewetting them to prevent emissions of greenhouse gases. And when we need to do these kinds of activities, it's important that we can monitor and verify carbon removal activities, so that we can also have a business model for the farmer. In order to have a proper business model, we need to assess the results of these activities to provide a legitimate payment. And in setting up this MARVIC framework, we are focusing on several aspects. Of course, we need to be in line with the regulatory framework for carbon removal certification, and there's a technical expert group set out by the Commission, where we're also involved in having some of these discussions about how to properly design these activities and what's the effect of different carbon farming practices. But it's also important to ensure that there's a proper balance between cost and trade-offs and accuracy in terms of monitoring. It's easy enough to develop, or it's also difficult to develop a monitoring system that is very accurate, but if it's also super costly, then it is not feasible in practice to implement. So having this right balance between cost and trade-off or accuracy is super important. And then we need to consider the risk of non-permanence by changing land management. The thing about soil carbon is that it's not a permanent storage. So in that sense, it's something we need to balance when we develop MRV systems, that these types of storage are not permanent. And also ensuring that we use the data that we have available and gather that in a complementary modular approach, combining different purposes and different geographical spatial variability of the data available. And it should also be attractive for land managers in terms of administrative and financial burdens. So we need to take end users' preferences for different ways of designing these MRV systems into account, and we're doing that in several work packages. And then it's also something that needs to be open source, because it should be applied by a wide range of different stakeholders. And we are focusing also on the post-project improvement potential and implementation. In terms of the context specificity, we consider different pedoclimatic conditions and farm types, focusing on some of the different practices that are available for sequestering carbon, and the different field size and farm size and levels of technology that exist across Europe. And we will also use different scheme types, different purposes for these MRV systems. Partly it's something that can support implementation of the CAP, but also private markets and different forms of insetting that are available. And one of the discussions that we are having is also the desired geographical coverage and accuracy. So what's the scale of actually implementing and designing these MRV approaches, and what's the data available across countries and across contexts at different levels of monitoring, but also in terms of different degrees of availability. so that the system becomes easy to connect with for farmers and can work with the existing data at farm level. Also taking into account the local policy context, of course, the European policy context and the different policies that influence what farmers do in their fields, but also national policies and what's available for farmers in terms of support and facilitation. Yeah, and finally, users' needs and preferences, because finally, this is something that will need to be taken up by farmers. So it's important to have their perspectives represented in the design of these systems that ultimately will be influential in terms of designing practices at farm level. And in terms of assembling data, we're very inspired by this model designed by Pete Smith et al. In the CIRCASA project. And the central idea is that you use long-term experiments at the benchmark sites as sort of the driver for this model, combining it with more short-term experiments, for instance, with respect to greenhouse gas fluxes. And then that functions as an input to design and calibrations of models that use different types of spatial data, activity data, and remote sensing as a way of quantifying carbon removals, and also using sampling in an intelligent strategy, using this modeling approach to decide sampling campaigns for monitoring and verification. And in terms of our approach in the project, the first work package, we follow an iterative approach, exploring, designing, testing, optimizing in the development of MRV framework by reviewing rules, processes, and guiding principles in existing MRV systems and identifying MRV options, developing strategies that integrate several MRV methodologies at farm level, and fine-tuning and finalizing in an MRV framework. And in the second work package, we focus very much on these different data sources and develop strategies for smart data use and cost-effective, scalable data acquisition techniques and tools for MRV activities at scales. Identifying the different data sources that can function as an input to MRV and how we can use these long-term experiments we have across partner countries as benchmark sites to also test the effects of different carbon farming practices and ranking these practices in terms of cost and accuracy and taking sort of opportunities for sampling into account. And finally, in the third work package, we focus on different modeling options in terms of establishing and validating methodological procedures to develop and improve or implement reliable and transparent models for monitoring soil carbon changes and stocks and also greenhouse gas fluxes, because that's also important to take into account when we develop these MRV protocols. It's not only about soil carbon, but also considering these wider greenhouse gas fluxes. Yeah, and the MRV model that we develop is then tested and fine-tuned across 26 sites across Europe at these 4 different types of land uses. Yeah, and aside from developing and proposing this MRV framework, we're also focusing on mapping and modeling where carbon farming works best across Europe, assessing the social and economic benefits of carbon farming. For a lot of land users, it's not enough to have an economic benefit from carbon farming, and for the most part, the economic benefits is not necessarily very big. So there are many other benefits of carbon farming that are traditionally more important for farmers. So we try to take stock of that and then keep having a dialogue with the end users in terms of improving designs, but also improving strategies for implementation. Yeah, and as you can see here from this final slide, there's a range of partners involved, and if you're interested, yeah, please get in touch either with any of these partners from the activities in the work packages or specific partners involved in these different land use categories. But this was my presentation, and thanks a lot for listening in.
Thank you, Martin. It was very super interesting. So we have David Robinson back with us, and maybe I would ask him to go with his presentation now. I think we can start from the beginning, David. So please go ahead.
So thanks. Yeah, sorry about that. It's so I think I was up to partners, 28 partners across 14 European countries, where we've got testing sites for the infrastructure, and it's all built around this idea of this data cube that forms the central component of the project, which is run by OpenGeoHub, and we're all contributing into that effort. And we've got lots of novel ways of trying to collect information, including things like infrared DNA, to try and feed into that. And then that will support a range of tools, web tools, apps, what have you, to see and visualize information. This means bringing together a lot of information, so the LUCAS soil samples, plus a whole range of remote sensing satellite information. And these are the sorts of outputs that we're looking at. At the moment, you can go to the Open Land Map site, you can see different soil layers that are in there, and visualize and look at the maps. The data cube is developed, and which is one of the problems now, that we're looking at how to best host that and to be able to visualize that. And the web portal in the lower left is coming. This is a web app, so it can be viewed online or it can be viewed on your phone. It has the ability to see and visualize the data that's put in there. It will also have the capability that you can put your own data in, and you can collect information and enter it through the web app. So this is one of the, I think, really sort of interesting outputs that we have at the moment, which is the carbon map, and is a time series. So goes through carbon through time. And of course, we're developing the infrastructure component of it, and this relies on data. So it's only as good as the data that underpins it. And so the more data that is available and that comes into the system, and it should get better and better with time. But the infrastructure is there to be able to see and to visualize. As I was saying, we do a lot of work with JRC and trying to produce products with them. One of the areas we've been working on is thinking about indicators and monitoring, and laying out the principles of that, and looking at indicator frameworks. So that work is developing and ongoing. In the center, this is one of the maps that was led by JRC that we contributed to, which is on bulk density across Europe. And we do quite a lot of interaction in that. Romatrey, in particularly, is working with soil erosion and leads efforts on that. Here at UKCEH, we've been looking at the soil organic carbon clay ratio as perhaps a novel indicator linked in with pedoclimatic zones, to help to better interpret that in terms of soil structure. One of the, I think, important aspects that we're dealing with now, which is led by Hamburg, is trying to put this together into some form of index. And we've created what we call this Soil Vulnerability Index, which uses machine learning and uses the data from LUCAS in terms of carbon, erosion, pH, and salinity models in the terms of erosion, and puts these together focused on the distribution. And we put this together in an index through a normalized of all of these. And then we're able to look at how the index fares across Europe, and look at how it changes through time. And that's the hope that that will progress, and that more soil variables will come into them, or indicators, and it gives us the capability to predict into the future as well. So those are just a few of the highlights that we have in the project. So I'll just finish up there and leave you with all the contributors. So thanks very much.
Thank you, David. Really impressive, I need to say. And finally, we have Dimitra Palanza from Aristotle University of Thessaloniki. Dimitra specialized in remote sensing for soil monitoring and contributes to MARVIC project. MARVIC is sister project of MARVIC, so funded under the same cause. So we will have the opportunity to hear from different projects working on MRV. Thank you for being with us, Dimitra, and over to you.
Thank you. Hello all, I'm Dimitra Palanza, and I will present the MARVIC project. And the title of my presentation is Bridging Remote Sensing and MRV, and I will present to you some insights, outcomes, and challenges from MARVIC project so far. So I will start with a short introduction around policy analysis for MRV in Europe and the current state in the agricultural sector. Current frameworks and initiatives, as it has been mentioned before, there is the carbon removal certification framework that has set guidelines for certifying carbon farming practices, and that includes a tiered approach monitoring methodology with tier 1, which is the basic method using default values from IPCC guidelines. Tier 2, using regional or national data set for improved accuracy. And of course, the tier 3, which is more advanced methodologies using site-specific information, remote sensing, and dynamic models, which is actually our main interest here. And then there is the third-party verification to ensure accuracy of reported data, and certification linked to registry to support transparency and market integration. Then, through the common agricultural policy that incorporates climate goals, providing financial incentives for sustainable practices, such as cover cropping, agroforestry, and reduced tillage, and encourages member states to submit strategic plans outlining MRV mechanisms. And finally, the Horizon Europe, that these initiatives test MRV methodologies, integrating remote sensing and AI tools to monitor shock changes. So based on all this, the MARVIC aims to design a comprehensive, robust, and cost-effective Tier 3 approach, accounting for changes in as many sea pools as possible, and estimate GHG and full sea budgets. So I will present to you what we have done so far. We are leading actually the work package 2, my team in Aristotle University of Thessaloniki, and mainly the task in remote sensing. So based on all this, so far we have designed in our first deliverable a reference data set of essential Tier 3 MRV indicators, as you can see here. And we are outlining at first the current Earth observation monitoring capacities and ready-to-use open data sets. That includes the proximal sensing, remote sensing, and open data sets. That all this can contribute to spatial explicit indicators and other high quality input layers. For example, like we can get soil data, soil texture, pH, and total nitrogen layers, climate data, land management, GHG emissions, that all this can be inputs to the process-based modelings. In the project, we will test many process-based modelings, and on top of it, the ORCID. And then finally, we have the harmonization issue. It's a big challenge, and we are trying to tackle it in our project since we have data sets from different, from many sources, as I have mentioned before. And of course, our outputs are going to be SOC sequestration layers and net GHG emissions from and monitoring from the sub-landscape, starting on the demo site level and trying to upscale it to the landscape level. So following this, I will show you now our workflow, how we have selected these specific remote sensing indicators to develop in the scope for MARVIC project. So we had to consider many aspects, how to develop these indicators, and we have to make a list. And so we considered the demo site leaders' needs, who are going to do the testing in their demo sites. What are they going to need from remote sensing? And we used a ranking system prioritizing the most important indicators from high to medium and to low. So after we asked the demo site leaders what they would need from us, we also made the prioritization process based on remote sensing, what is feasible with remote sensing to be done from these indicators. And finally, we considered our work package 3 leader and the ORCID modeler, their priorities in remote sensing. And we created this this table of the remote sensing indicators that you can see on the right, which includes soil indicators, song, sand, silt, clay, pH, total N, some land management from tillage to cover crops, HGB, and vegetation indices in various land use, land cover. So I would like to say that this table that you see, it's going to be updated before the end of the project. So this is our effort so far. And here is a comprehensive table that you can see the effort of our partners in various, that they will use various input data sets from many sources with advanced AI modelings in these various land uses. And with a lot of sensors that we tried to include. So not only, we didn't stay only on Sentinel-2, we included some hyperspectral sensors and UAV campaigns. And this is the expected output product that we have already been producing all this time. And here you can see the land uses we will cover from agroforestry, grasslands, forestry, and croplands. So based on that, I will go to some more technical slide, but quite simplified. This is a very simplified workflow of our AI modeling and an example for our agroforestry sites. You can see in this side various input data sets and layers. Here is the advanced AI modeling that our partners and we have done, and how we actually do, we test various AI models with metrics, and we end up to the geospatial layers that you see down here, the upper branch that leads to layers of SOC, pH, texture, total N, etc. But also another important branch that goes down is the uncertainty assessment of these products. This is actually a measure we took for harmonization, since the data sets and the AI is going to be from various partners, and we are not going to have the same sources. The PIR assessment that we will use for uncertainty, it's going to be a metric to evaluate the products. And this uncertainty is also it's like a quality control of the products. It shows the reliability of the products to the modelers, that they will use them as inputs to their process-based modeling, the dynamic modeling that will happen later. So especially for the soil properties, uncertainty maps are coming together. It's like a duo. So this is here an example of the metrics that we use to choose the optimal model, because a model can perform better in some and produce better results for some indicators, and another model can get better results in other indicators. So this is usually what we do. We compare models with metrics to see which, and the one that performs better, we use the specific layer as a reference. So here are the examples that I told you. You can see these maps, and it's from an agroforestry site in our project. And this is the clay product that you can see with its associated, the clay product is on the left and the associated uncertainty map is on the right. And this is a topsoil estimation of the property because remote sensing can only be used for a topsoil. And here is also the SOC product from the same demo site. So following this, some challenges and limitations so far that we have faced, and lessons learned from previous projects. In general, for the more precise tier 3 methodologies, we need the remote sensing products to have high spatial resolution. And this is some lessons learned from a previous project, the World Soils, that showed the limited capacities of Sentinel-2 and that the local models maybe outperform the continental models. And it highlights the importance of parcel level information, the LPIS systems. And then there is another issue, the data availability on the demo sites, because historical datasets or long-term monitoring are not always available on demo sites. So alternatively, we have to use the open sources, for example, from Lucas or Soil Grids, if applicable in the specific areas. And of course, another very important issue, and that we also try to tackle in the project, is the scalability from farm level to landscape, because not all indicators can be scalable. So following this, I would like to, before closing, I would like to show you how we will bring the knowledge, all the knowledge gained and the lessons learned and the products from the MARVIC SOC project to the public. This is a first design of our knowledge hub, which is going to be ready by the end of the project. And it's going to be our online data repository that will work as the public bridge between the stakeholders, scientists, land managers, farmers, policy makers, that they will have full access to our products. It's going to be open and accessible. And also they will be able to see the projects, because we will do the visualization of that. So yeah, this is our interface, the alpha version. Let's say we are going to present it close to the end of the project. And to conclude, some future perspectives around remote sensing within the MRV concept. There is a need for integration for advanced technologies, hyperspectral, superspectral data, and advanced AI modeling. And also, we need scalable and cost-effective solutions that will improve the soil and carbon monitoring, the tier 3 methodologies, and enhance decision support system and stakeholders empowerment. And finally, to conclude, the MARVIC4SOC project can contribute with methodologies in monitoring SOC prediction and SOC sequestration to the living labs with the similar and same soil objective regarding the soil emission. Thank you. This is the end from me.
Thank you, Dimitra. And now, as we've heard from all our speakers, it's time for a roundtable discussion. So I'd like to invite all our speakers back on screen whenever possible. And to kick things off, I'm monitoring the Q&A chat, but I'd start so you can type your questions there. And as I said before, we have collected also some questions during the registration phase, so from the registration form. So actually there were several questions, and we tried to group them by category. I would start maybe with a question on EU projects and funding opportunities. The question was, how can we find consortium partners in the European community to develop projects to test innovative technologies for managing soil potential in agricultural production under climate resilience conditions? Then, not sure, maybe Julia, would you like to address this one?
Yeah, thank you.
Thank
And
you.
thank you for the question. So one of the, as I mentioned in my presentation, we expect dedicated funding until the end of Horizon Europe to set up living labs. And living labs are one of the first area to and the first opportunity and environment in the mission soil to develop and test and validate innovative solutions. So for this, we need to wait for the upcoming funding opportunities. We need to wait for the publication of the 2025 Missions Work Program, including the funding opportunities for the Mission Soil that we expect, considering the publication time of 2024, not to arrive before the end of Q1 of 2025, but stay tuned in case something is happening sooner. And as we said, one of the SOIL is also supporting the applicants, and in this we will continue the matchmaking opportunities dedicated only to the living lab topics in SOIL. So enroll to the SOIL community to receive information of when the matchmaking platform will be available for you, and we will support the creation of consortia for these topics. For other mission soil topics where a more research-oriented activities is planned, in that case, again, you need to refer to the mission work program, but SOIL will not support the matchmaking. In that case, I recommend to interact with your national contact points to understand if dedicated matchmaking opportunities are organized. Just a clarification, since there is a specific mention to agricultural, please note that the agricultural land use types has been already addressed in the 2023 top-down topics for living labs. So in this sense, the future topics probably will not cover this thematic, but the agricultural land use types can still be considered alongside other land use types in the bottom-up topics to be expected in the future work programs.
Great, thank you, Julia. And I see there is a question on a paper on soil vulnerability index. So probably it was to Dimitra. So if possible, maybe you can type your answer in the Q&A box. And so we have also some questions on best soil microbial target measurement for carbon farming. So probably it would be for Martin. There is, I'm not sure, Martin. There was also a question from the chat now from Jonas Scheppens on for MARVIC project. Does the project also looks at co-benefits or trade-offs of increasing soil carbon stocks with other aspects of soil health?
Mostly we are looking at existing field trials and data in the MARVIC project, and finding novel ways to assemble that into some MRV systems. But of course, when we are doing this MRV, it's also important to consider these trade-offs, and especially with relation to greenhouse gas emissions. And yeah, that's also something that we are considering, and especially also in an economic aspect. I mean, what's the economic implications of different practices? The implications for yield, for instance, or the investments in time and energy is something we consider. So in that respect, we consider trade-offs, yes.
Okay, great. Thank you, Martin. So just raise another question. I have also a question for not sure, maybe Paolo or David. What contributions are you making towards indicator frameworks? There was a cluster meeting during European Soil Mission Week. Not sure, maybe you would like to say something about indicator frameworks?
David, go ahead.
Okay, David, bye.
Yeah, thanks, Paolo. So as Paolo was saying, that the Benchmarks project and the AI4Soil Health project, along with some others, are working within the cluster. And there are 3 of these clusters across the EU, where each of the projects has a representative, and we come together to look at how we develop and evolve the indicators. So in the last meeting, one of the areas that we were focusing on is thinking about frameworks, because and in frameworks we're thinking sort of soil quality, soil health, and especially across scales, because the indicators and the interpretation of indicators can be very different at a local scale as compared to a pan-European scale. And very often we're using different frameworks. So for instance, at the pan-European scale, if we're looking to interpret pH, we might be looking at broad scale indicators like thresholds of around 5, where aluminium starts to come into solution by geochemical reactions going on that are very widespread and underpin an indicator. However, if you're operating at the local scale, you may have a particular purpose, which is a certain crop, and the crop behaves in a certain way. So then your indicators and the interpretation are dictated by that crop. So part of the understanding the different frameworks is to get at those different purposes.
And maybe if I can add, and somehow more than answering, like addressing a bit the question you mentioned before, Gabriella, on what's the best microbe indicator for carbon farming. I think, of course, there's not one single, I cannot give an answer. There's not one single answer, because we would need to know exactly, we need more information, like the context and also the purpose of the carbon farming. So I would like to invite, especially the person who asked this question, but all the people joining the indicator meeting, because together we can try indeed to understand the different type of frameworks and also to highlight which indicator fits best, because maybe it's not only one, but there are multiple, not only from the microbial point of view. And that's something that we'll indeed are discussing in the indicator cluster. Yeah.
So this is something that was stressed in different presentations, that there is no one solution that fits all. And actually there was also a question, an interesting one thing, how to measure the health of your soil and its evolution through time if you are a small landowner. This is, I think, a kind of challenge that that's being addressed among different projects. So I don't know how, if someone wants to pick this up.
Well, I can start, of course, encouraging small landowners to interact with living labs. The living labs have multiple experimentation sites, and through the living labs and the living lab projects, indeed, there is a detailed planning for monitoring soil health and the progress. So if you, I really recommend small landowners or managers to interact with the existing living labs, or to consider joining, forming ones for the upcoming calls, to benefit of this more structured approach. Of course, I'm not entering into the technicalities that the colleagues from other projects can probably address better than me.
Thank you. Thank you, Julia, for this. I I think that in the Q&A box, the speakers are answering the questions. So not sure whether you would like to add something here by opening your mic. If not, we have actually there was another question on how to harmonize or standardize soil monitoring indicators through Europe. I think David was addressing this a bit, but if you want to add something about the indicators, monitoring indicators, harmonization. I
can say something briefly on that. Well, we have the soil monitoring law is developing and evolving. That has a suite of indicators that are part of that. I think if you put a bunch of soil scientists in a room, they will all agree that there are fundamental characteristics of soil that we should be measuring. So soil carbon, soil pH, bulk density. It was interesting in the UK, for instance, all the soil scientists got together and wrote an article in the Times and said, for us, you know, soil carbon is really fundamental, and we should be measuring it. It was completely agreed. So there is a set of indicators, I think, that are appropriate for that pan-European scale, but there will be other indicators then that are more suited to the local scale and might be only certain areas. So I think following what's happening in the soil monitoring law is an important start to look at the methods that they use there. They're all laid out, and then taking a steer from that. But you might need to adapt to your local situation, because there'll be certain things that are important in some areas and not so important in others.
Yes, this is something that Owen also stressed at the beginning of this webinar. Absolutely. Thank you, David. Thank you all. I have also a question. Rosanno, Philippe asked both. So there was a question for Paolo on the how drones can help to monitor soils, which sensors are getting developed to measure soil characteristics. And from same participant, there was a question for AI4Soil Health. Are you developing specific kind of prompting to make work more efficient? Yeah,
I wasn't quite sure that I understood that question. So prompting of what?
I think that it's because of AI involved in
well, I try interpreting it in the way that I see. I think one of the things that people often don't connect is the link between what we do with the monitoring and what we do with the AI systems and to interpret the data. And the design of the monitoring starts to become really important if you want to build an AI model. And a lot of mapping that was done early on was done on grid-based sampling. And that's great for mapping. But when you're trying to build AI models, you possibly want more nuance, and a stratified random approach can be really helpful in balancing out data in order to build models. So I'm not sure that answers the question, but that's towards this idea of saying perhaps in the way that you select data, the structure of the monitoring program will be important in how you generate AI models later on and what they are able to deliver.
Yes. So Rosanna, I'm not this answer has satisfied. If not, if they want to be also more specific, we can give you, we can open a mic for you. But as we are wrapping up, there is a last question for the for benchmarks. What is the proposed set of indicators in preparation by benchmarks and others, particularly concerning the biological indicators?
So as I quickly mentioned during the presentation, we have this this list, quite a wide list of indicators that we are currently testing. And we didn't test exact or measured or sampled for and measured everything everywhere, but we did already make a selection for a different type of systems that we have. And hopefully this will be shared. So the periodic report 1 has completed now. So also the deliverable all accepted. So this will be also available in Cordis. So this means that also the description of the sampling campaign and the list can be widely shared. And there's a list of indicators. In terms of the biological, of course, we have very preliminary results. And we already noticed that, for example, we do sample nematodes. And we are currently undergoing with the morphological identification as well as DNA-based identification. And we would like to compare the two and see if they give the same information. But starting already from the extraction from different parts of Europe, we see that in some cases, the nematodes can be used as indicators or as a biological indicator. But like in other parts, like in South Spain, it didn't rain for 10 months. We didn't have any to extract, really like counts of 9 or 10. So this is already like an indication how we have to be critical on which type of indicator to use. So we have included that, and on the biological side, we are going to base also on microbes, on microbial biomass, as well as DNA, so sequencing fungal and bacteria, as well as we are testing some functional genes, so with by qPCR. So different types also that can be easily accessible. Not everybody, I guess, would be able to do DNA sequencing. That is relatively expensive and maybe difficult to interpret, but with other methods, maybe it's a bit easier to understand your soil health. But this will come in the, at the moment, it's a screening phase, let's say.
Good. Thank you. So we've shared on chat the links to all the projects. So feel free to go and see also the deliverables that are public, as Paolo said. So there are plenty of information that you made access from this these documents. So I think as we come to the end of this our meeting today, our first thematic event, I want to extend a big thank you to all our speakers and participants. So remember that the recording and presentations will be shared with you in the coming days. So we will make them available on our website. And if you have further questions or would like to connect with the speakers or ask them, we can please reach out to us. We will try to accommodate and give you an answer. And last thing, I would like to ask you to take a minute to give us your feedback and also to suggest the topics that you want us to cover in the next webinars and thematic events. And thank you very much for today, and see you very soon for the next soil events. Bye-bye. Thank you.